In class, up to this point, we've been looking at how to build robots using these devices that we've been calling servos. Now, it's tempting to start thinking of a servo as being just this device, a plastic casing with this little metal thing on the end here. But it's very useful to learn what a servo actually is. As it turns out, we can find many different kinds of servos out there with different speeds, torques, voltages, currents, and so forth to meet the needs of our particular robot that we are designing and building. So today, we're going to learn about what a servo actually is by taking apart a servo and looking at the insides. To start out, remove this screw here. Your servo might actually possibly be missing this screw, but if you have this screw holding the servo horn onto the end, remove this screw. Now this part of the servo is known as the servo horn, and it's like a kind of a bracket that we use to attach any kind of a link that we want to attach to the rotor of the servo. And right now we're just going to pop off this servo horn. You might be able to pop it off with your hand. There we go. And so here we see that there are some gear teeth on the shaft of this servo. Next, to continue opening up this servo, remove the 4 screws down here at the bottom. Once you have all 4 of those screws removed, you want to pop off the back of this plastic casing, and that will reveal the circuitry inside. Now, let's pop off the top. Once you have those 4 screws removed, the top can also be popped off. So I'm going to pop this off very carefully. Remove the top plastic piece to reveal the gears inside. So inside of your servo should look like this. And what you'll notice is right here, this is the shaft of your motor, and then there's something else right over here, a little dial. Let's take a look at what the shaft of this motor and this little dial are doing on the inside of our servo. Going to take a P-sock, and I'm going to take a couple of jumper wires, and I'm going to connect the red wire of the servo, and then turn your P-sock over and find a VDD pin. I'm going to use this VDD pin right there. Then I'm going to use my other jumper wire to connect a ground pin. Here's a ground pin right there. I'm going to connect that to the black wire of my servo. Now, also, I'm going to connect the white wire to a pin that I can use as a digital output pin. So I'm going to flip the PSOC over, and I'm going to use pin 27 because it's easily accessible down here at the end. So flip the PSOC over, plug in this to pin 27. And now let's write some code in PSOC Creator. So go over to PSOC Creator and create a new project. Make sure you select the correct device. In my case, I have a regular PSOC 4100, 4200. You might have the BLE version, or you might have the M design version. So select the correct one that you want here. Make sure you've chosen empty schematic from this drop down, and I'm going to create a new workspace. I'm going to write a very simple code here just to try and send my servo to an angle. We've done this before, except now we're going to do it with the servo open so we can see what happens on the inside while we're doing this. So go to the digital menu and open up functions and find a PWM TCPWM mode. Drag it to the screen. Then go down to System and find a clock. Drag a clock to the screen and wire it up to the clock input. Zoom in a little bit so we can see. Nope, it didn't connect. So I'm going to try it again. There we go, the clock connected. Now I'm going to open up the ports and pins menu and get a digital output pin, and I'm going to wire it up to line. I'm also going to set the settings on my PWM right away. I'll set the prescaler to 4, which is the smallest prescaler we can use and still be able to get a 20 millisecond period. When I plug these numbers into my equation for calculating ticks from milliseconds, I find that the period needs to be 60,000. So I'll fill that in. And I'm also going to write a value to the compare that corresponds to sending the servo to its center position, and that is 4,500. I'll click OK. And then I'll go to set the pins. I only have one pin to set. This is pin 27 that we use to plug in the signal wire to the servo. Then I'll go to the main.c code, and I'm only going to write one line of code. I'm going to type PWM1 start. Then I will program the PSOC. So it will start by building my project. Now, when we look back at what the servo is doing, you'll see that the motor has started to turn at a constant speed. This is maybe behavior that you did not expect. Before we took the servo apart, when we downloaded this code, the servo would have gone to a position. So why is it now turning at a constant speed? The answer lies in this little dial over here. Try turning this little dial and look at what happens to the speed of the motor as you turn the dial. You should be able to find a position of that dial that causes the motor to stop turning. If you turn beyond that position, the motor will turn in the opposite direction. You'll also find that the position of the dial that makes the motor stop is right in the center. The dial can turn 180 degrees, just like your servo can turn 180 degrees. And the position of the dial that makes the motor stop is the position that you've commanded with the PWM, in this case, right in the center. Knowing this behavior, can you see how this servo works? This dial is a sensor. It's a kind of a sensor called a potentiometer. When we put the cap on to this servo, the gears connect this sensor to the shaft of the motor, so that when the shaft of the motor turns, the dial turns also. When the potentiometer gets to the center position, the motor stops turning. In other words, the position of the motor is set to the center. A servo is a device that combines two different devices, a motor and a sensor that detects the position. In this case, the sensor being used to detect the position is a potentiometer. Now, in order to put this device back together, we have to be careful about how we line up the potentiometer with the rest of the parts. First, unplug one of the wires to your servo so that it stops turning. Now, we need to make these two parts line up. On the servo cap, turn the shaft so that it is all the way as far clockwise as it can go. Now, turn the dial, the potentiometer shaft, also as far clockwise as it can go, and then these two parts should line up. So carefully slide the shaft of the motor into the little hole that is for it, and the cap should pop right on like that. Now, before you screw the top and the bottom together, let's check to make sure that we lined up these parts correctly. Take the servo horn and press it back on, and then make sure that the servo horn is able to rotate a full 180 degrees before it hits its stop. So here, I'm going to watch the little holes while I turn it and make sure it can go 180 degrees. If it can go 180 degrees, you can go ahead and put the back piece back on. You can see it has a little notch on it that lines up with the wires. And go ahead and screw these 4 screws back in. Then finally put the screw back in to hold the servo horn on. Now, this particular servo has its sensor inside of it, but not all servos have a sensor inside. Many servos have their sensor connected to the back shaft of the motor. I'm going to show you a couple of examples. Here I'm showing you a website called Pololu that sells lots of different kinds of motors. Pololu also sells servos, but they might not call them servos. You, however, can recognize servos on Pololu by knowing that a servo is just a motor that also has a sensor that reports its position. Look at these pictures of motors that I'm showing you here. This motor does not have a sensor attached to it, nor does this one. But this motor has this disc attached to the back of the motor. This disc is an encoder, and it's a type of sensor that's used for feeding back position. So this motor, even though it's called a gear motor, is a servo. It has both a motor and a sensor together in one package. Let's take a look at these. Here, you'll notice that there are many different motor models for sale at different speeds and different torques. They sell these different motor models in a model that comes with an encoder and in a model that does not come with an encoder. If you would buy the model without the encoder, you would be able to control the speed of the motor, but you would not be able to control its position. In order to control the position of the motor, you would have to get the version with the encoder. This version is a servo, even though it is not called a servo on the page. We know that a servo is any device that has both a motor and a sensor attached to it.